All right, boys and girls, so this is going to be a fraction review for the quiz that we're having tomorrow, Wednesday, May 6th. I am going to be reviewing the answers from the actual review that I assigned you yesterday on Google Classroom. So number one is 2/4 plus 3/4. Now, I want you, the reason why it's written out this way in word form instead of like standard fraction form, which would look like this, is because the whole point is we want you to understand that the fourths, okay, the denominator, that's your unit, okay? Your unit is not going to change. Think of it this way. If my unit was cupcakes and it said 2 cupcakes plus 3 cupcakes, how many cupcakes am I going to have? I'm going to have 5 cupcakes. So your unit, your denominator, fourths, it doesn't change. Look, here is 2/4 plus 3 more. Well, how many do I have in all? I have 1, 2, 3, 4, 5. I have 5/4. Do not, and I repeat, do not add the denominators, okay? All right, perfect. So here is number 2. Número dos is basically the same thing, except it's with eighths instead. So we have 6/8 here, right? So 6/8, and then the question is telling us to subtract, minus, take away 4 of those eighths. So look, here are my 6/8. 1, 2, 3, 4. How many eighths do I have left? I have 2/8 left. Again, when you are subtracting fractions with the same denominator, never, ever, 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 ever change the denominator because you still have eighths, right? You had 6 out of 8 and you're taking away 4 of those 8 and you have 2 of the 8 left, okay? All right, so number 3 says, Malia ran 6/10 of a mile on Saturday. Okay, so redraw right. So I'm just going to record it as 6/10 of a mile on Saturday and 7/10 on Sunday. Okay, cool. Malia is running a lot. That's good. So 6/10 of a mile on Saturday, 7/10 of a mile on Sunday. How many total miles did she run on the weekend? Well, I know the weekend is Saturday and Sunday. When the word problem says total, I know I'm looking for Saturday and Sunday combined. So remember again, my denominator stays the same and I'm just adding my fractions, my numerators. So I know that 6 plus 6 is 12 and 7 is 1 more than 6. So 6 plus 7 must be 13. Now this is an improper fraction, or as we call it, a fraction greater than 1. But because the question is not telling us to show the answer as a mixed number, we don't have to. If I want to show it as a mixed number, though, just to review it, because those types of questions are coming up, I'm going to pull out that 1 whole. Remember when we did this? We did it in the classroom in February and a little bit in March, and I'm doing it now for you. If I'm going to pull out a whole from this fraction greater than 1, my denominator is still 10. Well, how many 10/10ths do I need to make 1 whole? Well, we should remember that when the denominator and the numerator are the same, that's equal to 1 whole. So I just pulled out, this is like a number bond. I just pulled out 10 of those tenths. So how many tenths do I have left over? Well, 10 plus what number is 13, right? And it's 3. It's 3. So technically 13/10 is the same as 1 and 3/10 left over. Okay, that is how you would change a fraction greater than 1 to a mixed number. Remember, mixed number is a whole number and a fraction together. You know, we see them all over the place. Can I have 1 1/4 pounds of American cheese at the deli counter? Oh, look, it's only 2.5 miles until we get to the Palisades Mall. Okay, these are all examples of of mixed numbers. I am 10.5 years old, right? All right, let's move on to number 4. I know that some students had difficulty with this. It says, Brandon spent 3/8 of his money on Robux and he saved the rest. What fraction of his money did Brandon save? Okay, I'm going to draw a tape diagram for this. So this is what I'm solving for, right? This is how much he spent on Robux. And this is how much he saved. Well, think about it. What is the whole? What is this whole representing? All the money that he has. So we're talking about the money that he had for Robux and the money that he saved. All that money is going to equal one whole, right? And one whole, when we have a denominator of 8, is equal to 8/8. So if this entire whole is 8/8, how much of the 8/8 did he have left over to save once he spent 3/8 of that on Robux? Okay, so we can do that many ways. We can start with 3/8, right? And we can keep counting up until we get to 8/8. Or the opposite of counting up, it would be subtracting. So we can take all the money that he has, which is 8/8. It doesn't say it in the problem, but it's implied because the denominator is 8 and all of his money is represented by one whole. So that's all of his money. And then he spent 3/8 of it on Robux. So when you spend something, it goes away. You no longer have it. So you have to take it away by subtraction. Remember, the denominator stays the same. And if I have 8 and I take away 3, I'm going to be left with 5, right? And remember, the rules of subtraction and addition do not change when it comes to fractions. So if I want to check my work using the inverse operation of subtraction, which is addition, we would find that we're correct, right? 5/8 plus 3/8 is 8/8. So I know my answer is right. So what would go in we solved for the unknown, it's 5/8, right? See how that makes sense? He spent that on his Robux. So 5/8 is what he has left over to save. And when you add them together, it gets all the money that he had. Okay, so let me know. I know that one was a little tricky. If you still have problems with it, let me know. Happy to help you. The quiz is being released on Google Classroom tomorrow. However, you have until Sunday to complete it and hand it in. If you need more time, that's also not a problem. All right, moving on to number 5 that says complete the number sentence 2 3/4 plus what number is going to get me to 3. Okay, so I can look at this a few different ways. I can look at it as subtraction. I can look at it on a number line. I can look at it as drawing models. So that's what I'm going to do, actually. I'm going to draw models for you. I am going to start off with 2 whole, but I know that my denominator is 4, so my wholes are cut into 4 pieces. So watch. I have 2 wholes, right? That's representing my 2. I'm going to cut them into 4 pieces, and I'm going to shade all 8 pieces. This is going to represent my 2 wholes, right? 1 plus 1 is 2. Now I have 3/4. So I'm going to also do a model to represent 3/4. Here's 1/4, 2/4, and 3/4. So I want you guys to just take a look at what I did here, okay? So this is 1, 2, and 1, 2, 3/4, representing that. So how much more do I need to fill this in to make 3 holes? Right? How much more? I'm going to use a different color for you guys to show you. Don't mind my messy counter. Look, if I fill this in, will I have 3 holes? The answer is yes. Well, what is that fraction that I just filled in? It was 1/4. So 2 3/4 plus 1/4 is going to get me 3 holes. All right. So that was number 5. Number 6 is pretty much the same. It's just a different number. So I'm happy to do this one again to show you another example. We have to complete the number sentence 5 2/5 plus what unknown number is going to get me to 6 holes, right? Well, think about it. I already have 5. I already have 5. How many more fifths would I need to make this a whole to get up to 6? Right? So let's say I have 5. I'll draw it for you. 1, 2, 3, 4, 5. Actually, you know what? I decided since it's 5, I feel like odd numbers are easier to draw when you draw rectangles. So sorry about that. 1, 2, 3, 4, 5, 6. You might be saying, why are you drawing 6, Miss Lahosky? Well, it's because I know I have 5 whole numbers, but then I have a fraction left over that I need to represent, right? So if each of these are divided into 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? And so I have 5 holes. So technically 1 hole shaded, 2 holes, 3 holes, 4 holes, 5 holes. And here in my 6th, I have 2 of the 5 shaded. So see how I cut this into 5 pieces? 1, 2, 3, 4, 5. And I know that because my denominator is 5. And I'm going to shade 2 of those 5 pieces. 1, 2. Now look at it this way. What is left over to shade so that this 6th hole is completely shaded to represent the 6 holes? Well, let's look. 1, 2, 3. So the answer is 3, and my denominator stays the same, 3 fifths. Because look at it this way. If I add these two together, 2 fifths plus 3 fifths is 5 fifths. I hope we know now that 5 fifths, because the numerator and the denominator are the same, it's equal to 1. 5 plus 1 is 6. Okay? I know it seems a little hard, but use the strategies that you've seen in the videos. Use the strategies that you've learned. If the number line works for you, use the number line. If models work for you, use that. It's just, fractions are hard, and it's just, about practicing. So number 7 says, solve using any strategy and record your answer as a mixed number. Okay, so here we go. So here we have 3 fourths and we're adding 2 fourths. Now we know from the prior example, right? When we have 3 fourths and we add 2 fourths to it, we do know that we have 5 fourths. However, the question is not, we won't accept this for this particular question. We won't accept a fraction greater than 1, only because the question is telling us to record the final answer as a mixed number, okay? So how do I make this improper fraction a mixed number? Well, we can think about it as a number bond, okay? For an example, I'm just going to do a number bond with the number 6, right? This is what, Nikki is learning right now. So if this is a number bond for 6, you have to think 4 plus what number is going to get you to that total, right? So the unknown is 2. That's a number bond using whole numbers. So now let's think of it this way. We're going to pull out that 1 whole. So how many fourths, because 4 is my denominator, how many fourths would I need to make 1 whole? I hope you all said 4, right? If I have 5 fourths, okay, look at my example. I have 5 fourths and I used 4 of them to make a whole, right? Check it out. 4 of them to make a whole. And here's my 5th. It's kind of showing me that I have 1 fourth left over after the whole, right? Here's my 4 fourths, 1, 2, 3, 4, representing my whole, which is right here. And here is my 5th fourth left over, which kind of goes there, right? So my leftover is 1 fourth. So this can be rewritten as 5 fourths is equal to 1 and 1 fourth, 1 whole and 1 fourth left over. Okay? All right, so those were questions 1 through 7. I'm going to make a second video for the rest because I don't want it to get too long.